So here's a quick, just real quick, making sure that you remember temperature and how it relates to gas laws. But why does a thermometer work in the first place? Well, thermometers used to have mercury in them. Now we have an alcohol-based substance in it. When the temperature increases, that level will go up. And the reason the level goes up, it's just kind of to run through this, the molecules of the liquid in the thermometer move faster and they start spreading out, expanding. So when they do that, they move up. When it's cooled, they contract and go a little closer. A few quick things here. Remember, it's the average kinetic energy. I say remember because a lot of this was covered in middle school science, but just to quickly go through this here. The temperature at which particles have no kinetic energy is something we call absolute zero. Now, obviously, we can't reach absolute zero here on Earth. There's a few places in outer space we can do that. But that's why we use Kelvin. Remember, we have Kelvin, we have Fahrenheit, Celsius, and Kelvin. So Kelvin over here makes sense because zero is zero. And you can see here that the Fahrenheit scale, we have a bunch of landmarks here that we use. I don't know why it says 96, 98.6 is the typical one, but anyway, Daniel Fahrenheit came up with this scale, and he used actually something called brine, which is this is a one-to-one mix of ice, water, and ammonium chloride. You know, pretty normal, typical things you have sitting around. That's why it's standard, right? But here in the United States, we use Fahrenheit. Everywhere else in the world is going to use Celsius because it's based off of the properties of water. It makes sense. And then Kelvin is actually the one we're going to use in our gas law calculations that are coming up anytime there's temperature. So if you kind of look at this here, this shows the three different scales. You can use the scale kind of shows here that where absolute zero is here, where water freezes here, where water boils here. Again, you're most familiar with this one. This one we've kind of talked about in chemistry as being the system international, the international system of units, and then this one here is going to be used in gas laws. You can use these two equations right here, and that's going to help you with calculating or making your conversions. Not too tough. Typically, we'll be using this one right here, where you're going to get a Celsius. So you just add 273 here. So nothing too difficult, but make sure you use these. So just to sort of look at some examples here, if you were given, excuse me, if you were given a Celsius temperature, like negative 78 degrees Celsius, and you're asked to convert it to Kelvin, you'd simply just take that Celsius and add 273 to it. And because it's a negative number, you get 195, a little smaller number than you started with as far as 273 goes. And the next one says find the difference in temperature between the melting point of ice and the boiling point of water in Celsius and Kelvin scales. And you can see here that, of course, when you're talking about melting point, it's 0 and 273 because you just add 273 to 0. And then when you're talking about boiling point, it's 103, 373. So not tough stuff and something you've probably done before. The last thing we should talk about is something called STP, which is just standard temperature and pressure. And standard temperature and pressure is what we're going to, it's a phrase that's thrown out, or an acronym that you're just going to throw out, that basically means it's going to be 0 degrees Celsius, which, as we know, is 273 Kelvin, which is typically the one we're going to use. So if it says this sample was held at STP, you can assume the T of STP is 273. Now, what is the pressure? The pressure is going to be one of two things, probably 1 atmosphere. That's the most likely one. Now, every once in a while, we'll do an example later that talks about this. It'll actually have 101,325 kilopascals, and kilopascals is a commonly used one also. But anytime you see STP, you know what they're talking about. Typically, it's going to be these two right here. Standard temperature is 273. Standard pressure is 1 atmosphere. Again, these other two can come into play, but you really always have to go with Kelvin. And you can go with either one here. It's just atmosphere is preferred.